All right, so we're going to find out how to write the equation of a quadratic function given the graph. So, or if you're given points. So the first thing to remember is to write the equation of a line, or to define a line. We need 2 points, and lines are degree 1. So to define a quadratic, or its graph, which is a parabola, we need 3 points, because of the idea from polynomials that we talked about, that it's one more. If you add a degree, a quadratic is degree 2. If you add a degree, you add 1 kind of to everything. So defining a line, it takes 2 points. So to define a parabola, we need 3 points. So here's an example that we would do. This is not from the graph, but it's given 3 points. If I gave you the graph, you could pull your own 3 points off the graph, any 3 points you like. So how are we going to find the equation from these 3 points is the question. Well, since none of them are the vertex, I'm not told that they're the vertex, I can't use vertex form. We'll look at that one in a minute. When I don't know any of the points are vertices, if none of them's a vertex, I have to use standard form. Oops. So what I'm going to do is I'm going to plug one of the points in for x and y. So negative 11 and that'll give me my equation. If I simplify that equation, I get 4a minus 2b plus c. That equation, the problem with it is we have 3 variables. So we can't solve for any one of them with one equation. We need 3 equations since there are 3 variables. And we'll make a system of 3 equations. And that's how we will solve them. That's why we need 3 points. So I'm going to write another equation based off the general form or standard form of a quadratic and the next point for 13. So I plug in 13 for y. I plug in 4 for x, and when I square it, I get 16. I plug in 4 for x, so I get plus 4b plus c. The third equation will come from when I plug in 629 into the standard form of a quadratic. So it's 29 equals 6 squared is 36a plus 6b plus c. This is a 3 by 3 system. 3 variables. I have 3 equations. So now I can solve it. We usually write a system, each equation in the system, on top of each other, and then put the fancy brackets. We've done this before, but with 2 variables and 2 equations. So now I'm going to do elimination. I have to eliminate each variable one at a time till I get down to just 1 variable so I can solve for it. So I'll take the first 2 equations. I'm going to multiply the second equation by negative 1. So I get actually negative 13 equals negative 16a minus 4b minus c. The reason I did that is when I add these equations, that will eliminate my c. c minus c is 0. So now I've got negative 24 equals negative 12a minus 6b. That's my new equation. It's got 2 variables in it, so it's still not good enough. I need to get down to 1 variable. So I need another equation that has just a and b in it. And then I can combine this equation that I have here with this one with the new equation. So the way I get the new equation is I'll combine 2 other equations of the original to eliminate original equations to eliminate c. So I'll use the second and third equation. And I'm going to multiply the second one by a negative 1. This way, when I add them, The c's eliminate. So this will be negative, 29 minus 13, 16. 36 minus 16 is negative 20, because it was negative 36 minus 16. And then I've got minus 2b. So that is my second equation that has a and b in it. So now I'm going to take those two equations and eliminate either the a or the b. So it looks like if I multiply the top equation by 3, I can eliminate my b's. So negative 48, negative 60a, and minus 6b. I should have got, I needed a positive b up top, so I should multiply by a negative 3. So these all became positive. So 48 minus 24 is 24. And then the 60 minus the 12 is 48. And those equal 0. This is my newest equation. Now it's got one variable, so I can solve for it. So if I divide both sides by 48, I get a is 1/2. So now I can start filling in my a, my b, and my c up here. So my final answer will be here. Y equals 1/2, because that was a, x squared. Now I need b and c. So I take my a is 1/2 and I plug it in for a into my second set of equations, either here or here. Either one will work. I plug that in for a and solve for b. So I'm going to just choose this one. Negative 16 equals negative 20 times 1/2, because that's what a is, minus 2b. So now I add 10, and b equals 3. So now I've got my b, I've got my a, so I can go fill in. Now for b, I have 3, so it's plus 3x. And now I just need to find my c. The way I find c is I take my a and my b, and I fill it into any one of these original equations. So I'm going to choose the first one. Negative 11 equals 4 times 1/2 minus 2 times 3 plus c. And I can solve that for c. And you get c equals 7. Negative 7. So that's my last one. So I plug that in here, negative 7. This is the equation, and that is how you do it from 3 points.